In this lecture, due to the special demand, we have extended the series of beams, and in this lecture we are going to study the virtual work method on the beams to find different reaction on the beams. In the previous lectures we have studied the equilibrium condition method. If you have any doubt regarding the equilibrium condition method, just go through the previous videos. Okay, so let's start this video. So virtual work method. In this virtual work method, it is assumed that work is taking place due to a single force. That is, if a five forces are acting in various directions on a beam, then also we assume that the force which we have to find, the force F which we have to find to be the only force, to be the only single force due to which work is taking place on the beam. Okay, so that is the first condition. Then we write the work done for every force you have to find. Means we have to find the force F, then we write the work done equation for the force F. Okay, if we have to find the force R, then we will write the work done equation for force R. Okay, like that. And then we will sum up the work done equation for the single force, that is F, and equate it to 0. That means we will take the work done is equal to 0. Now let's see the sign conventions. The sign conventions of the virtual work method are different from the equilibrium condition method. In the equilibrium condition method, we took that x-axis, y-axis, y-dash axis and x-dash axis. Everything along the x-dash axis, forces along the x-dash axis are negative, along x-axis are positive, along y-axis are positive, and along y-dash axis are negative. This was the general sign convention for the equilibrium equations. But the sign conventions for the virtual work method is something different. The forces in the directions of displacement is positive, and the forces opposite to the direction of displacement are negative. Okay, so let's assume that this is a beam. Okay, it have displacement done something delta. Okay, something delta displacement is done. Here somewhere there is a force of 5 kilonewton acting, and here somewhere there is a force of 8 kilonewton acting. Okay, and the displacement is in upward direction. So the 5 kilonewton here is acting in downward direction and displacement is upward direction. So we will take this 5 kilonewton to be negative, to be minus. The force 5 kilonewton in the work done equation will be taken minus. And here the 8 kilonewton is in the direction of displacement, so we will take it positive in the work done equation. Okay, that is what it is given in these two sentences. And the clockwise moment is positive and anti-clockwise moment is negative, as it is same in the equilibrium condition equation. So let's see an example. Find the reactions Ra and Rb. Okay, this is point A, this is point B, a beam AB. Okay, on A there is a simple support, on A there is a simple support, on B there is a roller support. Okay, at a 2 meter distance from A, there is a point C on which a 40 kilonewton force is acting in a perpendicularly downward direction. From point C at a 4 meter distance, there is point D on which a force 80 kilonewton is acting in perpendicularly downward direction. Okay, downward direction. And from point D at a 1 meter distance, the beam is ending at the point B on which there is a roller support. Let's draw the FBD. So this will be the forces acting on the RA, and RB will be the forces acting on point A and point B in perpendicularly upward direction, which is upward direction. Okay, so first of all we will consider for RA. We will consider that the displacement is taking place due to the RA. First we will find RA. So we assumed that somewhat a delta displacement has taken place due to RA. Okay, and now the beam which we know AB is displaced to this position, And now we will assume that this point is A dash and this point is B. We know that this point is B. We will assume that this point is C dash and this point is C. At 40 kN force is acting perpendicularly downward, we know that. And let the displacement here will be delta 1. And this point is D. So let this point be D dash and the displacement here be delta 2. Okay. See here. I have drawn here C delta, delta 1, delta 2. Here it was a 40 kilonewton force and here there is a 80 kilonewton force. So first of all we will find what are the values of delta 1 and what are the value for the delta 2. So how we will find the delta 1 and delta 2? We will find it by the similar triangle method. Similar triangle method. This method we have learned in 10th standard for geometry. Okay. So see here, we will take delta upon the total distance, that is 2 plus 4 plus 1, that is 7, equal to delta 1 upon 4 plus 1, that is 5, equal to delta 2 upon 1, this distance is 1. We will take this equation from the similar triangle method. Okay, that is this, if this is a triangle A dash AB, this is a triangle C dash CB, and this is a triangle D dash DB. Okay, if we consider these three triangle will be similar, and from that point of view delta 1 and delta 2 will be similar somewhat upon the distances of the base, that is 7, 5 and 1. Okay, see here we have taken here for, that is triangle A dash AB, triangle C dash CB and triangle D dash DB are similar. So we get this equation, and from this equation we get delta 1 equal to 5 delta upon 7 and delta equal to delta 2 equal to delta upon 7. We get this. Okay. So moving further, now we will write the equilibrium, we will write the virtual work done equation, not equilibrium, we will write the virtual work done equation. So what will be the virtual work done equation? First of all, we know that work is equal to force into displacement. This is the standard formula. So using this formula, we are going to write the equation. So first of all, we will take the force RA. Okay, RA into the displacement is delta. So into delta. Now see, we will take this force. It was 40 kilonewton. So 40 into displacement kya hai? Delta 1. Okay, and here it is 80 kilonewton. So 80 into displacement is delta 2. 80 into delta 2. And we will equate it to 0. Okay, but the displacement here is in upward direction. Because RA is in upward direction, so displacement is upward direction. This 40 kilonewton is in downward direction, so this will be minus. Here the 80 kilonewton is in downward direction, so this will be minus. Why? Because displacement upward and the force downward, so minus. But here the displacement is in upward direction and the force RA is also in upward direction, so this will be positive. Okay, so rewriting the equation, we get delta W, the virtual work done, equal to 0, that is RA into displacement delta minus 40 into delta 1 minus 80 into delta 2 equal to 0. But we know that the value of delta 1 and delta 2, so we will put it in this equation. When we put the value of delta 1 and delta 2 in this equation, we get, what do we get? See here, we get delta RA minus 40 into 5 delta by 7 minus 80 into delta by 7. Okay, we multiply each term by 7, then we get 7 delta RA minus 200 delta minus 80 delta equal to 0. If we take delta common, then delta into 7 Ra minus 280. But delta is displacement, so delta cannot be equal to 0. So we take, what do we take? 7 Ra minus 280 equal to 0. So we get Ra equal to 40 kilonewton. Now we will solve for the value of Rb. Okay, so we took that the displacement taking place is due to Rb. Okay, so point B becomes B dash, so point D becomes D dash. On point D there was a 80 kilonewton force. Okay, on point C the displacement becomes delta 2. Okay, and it has the force of 40 kilonewton. But remember, from Ra we have delta 1 and delta 2, but the delta 1 and delta 2 of Ra are not equal to the delta 1 and delta 2 of Rb. Okay, that is the point of consideration. Okay, so now we will find the value of delta 1 and delta 2 in the terms of delta using the similar triangle theorem. So using the similar triangle theorem we get delta upon 7, that is the total distance. See here, 1 plus 4 5 6 7, that is delta upon 7 equal to delta 1 upon, see here, from delta 1 4 plus 2, that is 6, and delta 2 upon this is 2, so 2. Okay, so we have written the equation. From that we get delta 1 equal to 6 delta by 7 and delta 2 equal to 2 delta by 7. Now we will write the virtual work done equation. So first of all, for writing the equation we know that Rb, we will write the equation as Rb into displacement is delta. Then here the force was 80 kilonewton. What it was? 80 kilonewton. So 80 into delta 1, and here the force was 40 kilonewton. So 40 into delta 2 equal to 0. Okay. Here the displacement is in upward direction and Rb is also in upward direction. So this Rb into delta is positive. At point D, the force 80 kilonewton is in downward direction, but the displacement is in upward direction. So this will be negative. And same in this case, it is 40 kilonewton in downward direction, but the displacement is upward direction. So this will be negative. Okay. So we get this type of equation. Virtual work done equal to 0. So Rb into delta minus 80 into delta 1 minus 40 into delta 2 equal to 0. So now we will put the value delta 1 and delta 2 in this equation. So what do we get? We get delta Rb minus 80 into 6 delta by 7 minus 40 into 2 delta by 7. So we will multiply each term by 7, then we get this equation, and here we take delta common. So Rb 7 Rb minus 560 equal to 0. But displacement, that is delta, cannot be equal to 0. So 7 Rb minus 560 equal to 0, and we get Rb equal to 80 kilonewton. Thank you for watching this video. In next video we are going to solve another example on the virtual work method. Stay tuned. Bye.